good evening, good afternoon, or good morning. We are Group 2 from BS Geodetic Engineering 1201, and here is our Python code entitled Lot Surveying Made Easy, Accurate Technical Descriptions Generator and Calculator. Next slide, please. And as per the overview of our Python program, this is a Python script that connects to a MySQL database and allows the user to add data to the database and perform calculations on the data. The script contains a menu of 5 options, including view the database, add to database, perform a shoelace calculation to get the area of the lot, perform a haversine calculation to calculate the distances between 2 points, and convert DMS notation to AutoCAD polyline commands. The script uses the MySQL connector library to connect the database and perform database operations and calculations.
Okay, so once again, our final project for Computer Programming 1, which is also a Python project, is entitled Lot Surveying Made Easy, Accurate Technical Descriptions Generator and Calculator. The goal or the primary objective by this project is to assist engineers, mostly those who are affiliated with data gathering processes in a particular location, by the means of the calculation of the various data that they may input into the program, as well as the storing and retrieving of those calculated data or information. Our project hopefully targets to aid both students and professionals working in the field of physical surveying. The program offers key calculations beneficial for the treatment of raw data, such as area and distance points calculation. Also, our project has the feature of importing the data to AutoCAD, allowing for recreational models and representation through visualization. Summarizing the points iterated thus far, this program is devised for it to be a useful tool for our target users, since it offers beneficial functions. Firstly is the various types of data calculation in the program. Secondly, keeping track of the valuable gathered and calculated data. And lastly, the visualization of those data. This specific Python project should allow for a convenient, hassle-free experience for the users, hence aiding them in their field of work.
This is a Python script that provides a menu-based interface for various surveying calculations. The script uses the MySQL connector module to connect to a MySQL database and retrieve data from it. The script also includes 3 functions for surveying calculations. First is the shoelace algorithm is a formula that uses the coordinates of polygons vertices to calculate its area. It gets its name from the pattern that emerges when you multiply and add up the coordinates. Second is the Haversine's formula for computing the distance between 2 points on a sphere given their latitudes and longitudes. And last is a function that converts decimal degree latitude and longitude values to degree minute seconds or DMS notation and generates an AutoCAD polyline command using those DMS values.
To further explain the function, this script starts by presenting a menu with 5 options. View the database, add data to the database, perform a shoelace calculation, perform a Haversine's calculation, or perform a DMS notation conversion. The user can select an option by typing the corresponding number or letters. If the user select option 1, the script connects to a MySQL database and retrieve all the rows from a table named TBL survey data. The rows are then printed to the console. If the user select option 2, the script prompts the user to input necessary information and later after that, the program inputs the acquired data to the MySQL database. If the user select option 3, this script prompts the user to enter the number of vertices of a polygon and the x and y coordinates of each vertex. The shoelace algorithm is then used to compute the area of polygon, and the result is printed to the console. If the user select option 4, the script prompts the user to enter the latitude and longitude value of 2 points. The Haversine's formula is then used to compute the distance between 2 points, and the result is printed to the console. If the user select option 5, the script prompts the user to enter the latitude and longitude value in decimal degree, as well as the bearing and distance of the line. The script then converts the latitude and longitude to DMS notation and generates an AutoCAD polyline command using the DMS values. Finally, the script loops back to the beginning of the menu, allowing the user to perform additional calculation or exit the script by typing Q. So, that would be all for our program presentation. We are Group 3, Land Surveying Made Easy. Thank you for listening. Goodbye.